Okay, today we're going to go over vertical transformations of quadratics. So we're going to write an equation here. And the very first thing we need to go over, example 1, is what this is considered our original, okay? So our normal parabola. This is a quadratic equation. Y is equal to x squared. We know it's not going to create a straight line because x is to the power of 2. Okay, so we're going to quickly go over how to draw that. What's going to happen is this is going to have a vertice at the origin, 0 and 0. Okay, and then you could use a table to draw this, but we're going to learn a trick to go through it. I'll create a small table on the side just so you guys understand. Nope, I don't want that. There we go. We'll make a small table on the side here, just so you guys realize what we're doing. These are our x values and our y values, okay? So let's say we plug in x as 1. If I were to put 1 for x in this equation, what is 1 squared? So y will be equal to what? 1. Good. So that means we're going to have a coordinate at 1 and 1. Okay? That same idea, let's say we put in negative 1. If I were to square negative 1, what happens?
1.
Yeah, we get positive 1. Okay? Because we're squaring our number, we're always going to end up with a positive y value, assuming there's no negative sign in front of the x. So at negative 1, you guys will notice this is a mirror image of our other one. Okay? So what's going to happen is pretty much however far away I go from the vertex to the right or in a positive direction, the mirror image is going to happen to the left for now. And especially with our original one. As we go on, things might change. But this is a fast way of drawing it. Okay? So then, since we know that's going to be in mirror image, our y value is going to be 1. Let's say we do the value of 2. Okay? And from now on, we'll just do positive numbers and put the mirror image on the left side of it. So, positive number 2. If I were to put y is equal to 2 squared, that's replacing the x over here, what would I get as a y value?
4.
4. Excellent. Okay?
So why is there 1 point?
Why is there 1 what?
1 point, like on x and y. Why is there's 2, there's a 1, and 1.
We just went over that. Okay, 2 and then up 4. I'll explain it after. Okay. So we go over 2, up 4. Again, we're going to have the mirror image of it. So that's back 2 and then up 4. Okay? Now, instead of plugging it into this equation every time, we're going to try to do this in our head. So let's now say we move 3 away from the vertex. We just have to square that value. So what is 3 squared?
9.
9. So we know our y value is going to be 9. And if we were to go back 3 and we were to square negative 3, what would we get? Not negative 9. Positive 9. Okay? So from there, we essentially just need to connect the dots. Okay? Now, let's just, for argument's sake, let's say we went over to 5. How far up will we have to go for our y value? 25. We'd have to square our 5. What if we went over 10 from the vertex? How much would we go up? 10 squared would be what? Oops. 100. Okay? So that's the idea of drawing the original one. Now, I know we spent a lot of time on that. Let's talk about actually moving this up and down. So, for vertical transformations, we're looking at an equation that looks like this. Y is equal to x squared, and then plus, yes, k is the variable we use. Okay? Some other books, I think, call it c, something like that. Doesn't really matter. Essentially, what we're looking at is we're looking at a number that is added or subtracted after our x squared. Okay? So this number is going to tell us how to move our parabola. So for instance, let's do it in blue. Let's say we have our equation here, so we'll call this equation 1. Y is equal to x squared plus 3. What that means is we're going to take the vertex of the original, and we're going to move it up 3 units. 1, 2, 3. This is where the new vertex is. Okay? So since that's where the new vertex is, we draw it in. And then from the vertex, I go over 1. 1 squared is what? Up 1. And then I do the mirror image on the left. From that same vertex, we go over 2. 2 squared is? So I go up 4 from there. 1, 2, 3, 4. Go back to the vertex. Let's say we go over 3 units. 3 squared is? 9. Well, that won't even fit on here. So let's just do with what we have. So this blue graph, or parabola, represents our first equation. That k value moved the parabola up 3. Okay? We'll do one more, and then I'm going to jump to a program that will help us out with this. X squared minus 5. Who thinks they know what we're going to do with that vertex now? Anyone know? Mark. Exactly. We're going to take this vertex and go down 1, 2, 3, 4, 5. Now, in the blue one, I showed you how you could redraw it from the vertex. Say you've already drawn the original, you can actually take all these major points and just move them down 5 also. So let's say we took this major point, we went 1, 2, 3, 4, 5. Here's where it would be. And if you notice, in reference to the vertex, that's right now over 1 and up 1. Okay? Let's say we took the next major point. Over here, we moved it down 5. 1, 2, 3, 4, 5. Here's what it would be. Here's the mirror image. And again, in reference to the vertex, we went over 2 and up 1, 2, 3, 4. So either way you could do this. You can redraw from the vertex, or you can just shift the original one up, down, depending on the number that's been given to you. And the next one would be a... what are we doing? 1, 2, 3, 4, 5. There we go. Here's our mirror. So our red parabola represents the equation of x squared minus 5. Okay. And just to confirm this, I'm going to show you that program. Here's our original. Let's say we draw another one. And this one, we say we had plus 4. And if you notice, instantly they move the vertex up 4. It's the exact same shape as before. Don't worry about that. Y equals x to the power of 2. And this one will go down 6. You might have to zoom out a bit for that, which I don't quite remember how to do. Oh, I do remember. Never mind. There we go. And if you notice, the vertex is at 6. The other one's at 4. And we can create multiple transformations of the exact same parabola just by changing that k value. If it's a positive value, we move it up. If it's a negative value, we move it down. That's vertical transformations.